Okay, so consider this numerical of superposition theorem, which is being shared on your screen. So it shows this circuit which has one voltage source and one current source. And we are required to calculate the current which is flowing in these resistances. Okay, so we will take one energy source at a time. So let's begin with taking the 2 ampere current source and short circuiting the voltage source. Okay, so when we do this, what happens? We are short circuiting these, and when 2 ampere current is flowing, so this is the direction of the 2 ampere current. And when this node is coming, now this node is appearing. So this current is evenly distributed between these two. So it is 1 ampere, 1 ampere. Okay. So the current will not flow in this branch. Okay. Why so? Because it is having the short circuit path in the form of CD. Okay. So it is the principle of current flow that it follows the least resistive path. So the current which is following this path, it has the least resistive path here. So it will flow in this manner, and again this 1 ampere current will flow in this manner. Okay. So, but what we are interested in, we are interested in the current flow in the resistances. Okay. So this BE current, in this BE branch, there will be no resistance, and other two branches, AG and GF, will have 1 ampere current each, and direction I have just mentioned. Okay. So next step is to open circuit this current source. Now this voltage source is active. So first of all, we will calculate the effective resistance of the circuit. So now this 5 ohm and 5 ohm, this 10 ohms, it becomes 10 ohms. This is also 10 ohm, but these two are in parallel. Okay. When the current will flow in this direction, it will be distributed at the node B. Okay. So 10 ohm is parallel with 10 ohm. It will give the result 5 ohms. So voltage source is 10, resistance is 5. So current flowing into the circuit from the voltage source will be 2 amperes. Okay. So now let's see the current which is flowing. So this is 10. This is 10. It is same. Okay. So when the current is flowing through this voltage source, it will be equally divided. So 1 ampere will flow through this, 1 ampere will flow through this. Okay. So the current through the BE is 1 ampere, and current through the AG is 1 ampere, and GF is again 1 ampere. Okay. So now using superposition theorem, we will determine the algebraic sum of the current flowing through various resistances. Okay, so in the BE resistance, no current was flowing earlier. Now 1 ampere current is flowing. So the effective resistance, effective current, so the effective current which is flowing through the BE resistance is 1 ampere. And now consider the AG branch or resistance AG. Earlier in the first part, the 1 ampere current was flowing in upward direction, but in the second part, 1 ampere current was flowing in the downward direction. So it results in 0. But as far as GF is considered, 1 ampere was flowing earlier and also 1 ampere in the later part. So 1 and 1 becomes 2. Okay. So in this way, we can apply the superposition principle. Is this clear to everyone? Okay. Let's move to another numerical. So in this numerical, we are having 3 voltage sources. This is the circuit which we are talking of. 3 voltage sources are given and 3 resistances are given. So we will take one voltage source at a time and short circuit the other voltage sources. Okay, and we will calculate the current through each resistance, and then we will add the current which is flowing through the 3 ohm resistance. Okay, we are required to calculate the current through 3 ohm resistance using superposition theorem. Okay, so 3 possibilities are there. First of all, we will make this voltage source active and other two will be short circuited. Okay, so we will get this circuit. Now, if we are going to solve this, what is the effective resistance of this circuit? These 2 ohm and these 2 ohm are in parallel, and this parallel combination is in series with this 3 ohm. Okay, as I have told earlier also, if you feel a bit confused, then you can place this resistance here so that it is more appealing that this is in this series. Otherwise, some students make a mistake that since this 3 ohm, this 2 ohm, this 2 ohm all are in vertical position, so they are in parallel, but it is not the truth. Okay, truth is that this 3 ohm resistance is in series combination with the parallel combination of these 2 ohm resistances. Okay, so we can calculate the effective resistance like this, and voltage is 2 volts. So V upon R is the current which is flowing through the load or 3 ohm resistance, and it works out to be 0.5 amperes. Okay, this 2 ohm and 2 ohm, when they are in parallel, it will result in 1 ohm, and 2 upon 4 gives 0.5. Okay, now consider second circuit. So in this circuit, we suppress the two voltages, short circuiting them, and only this voltage source is active. So its positive terminal is below. So current will flow in this direction as shown here. Okay. So when this current is flowing, so now these 3 ohm and 3 ohm, 3 ohm and 2 ohm, it becomes in parallel, and it is in series with the 2 ohm resistance, this 2 ohm resistance. Okay. So it is calculated as 3.2. So after calculating the effective resistance, we can calculate the current which is flowing through the load 3 ohm, and it comes out to be 0.375. Okay, this is the current which is flowing through this. This is the total current which is flowing in this circuit. So after calculating the total circuit current which is flowing in this circuit, we know the current division formula. Okay, so this is the total current, and to calculate the current which is flowing in this 3 ohm resistance, what we are required to do, resistance of other parallel combination upon this sum of the two. So this is done 2 upon 5. Okay, this we have derived 2-3 times earlier as well, and also you have done in class 12th. So it comes out to be 0.375. And next is that we will calculate now this E1 and E3 are short circuited and E2 is made active. Okay. So when E2 is made active, this circuit comes into the picture. So here again 2 ohm is in series, and since the current is divided in 3 ohm and 2 ohm, these two become in parallel. Okay. So we can calculate. This is the effective resistance. Effective resistance is same, 3.2. But since the voltage source is 1 volt, so the current which is flowing becomes 1 upon 3.2. And again, to calculate the current which is flowing to the load 3 ohm, we have multiplied by 2 by 5 to get the result 0.125. Okay, this is just a simple mathematics, you can do so. So now we are in position to calculate the total load current which is flowing through the load 3 ohms. And what we have to do, we have to add these currents algebraically. Okay, so what does this mean? That we have to do the vector addition and the direction of the current is to be taken into the account. Okay, so when we have calculated the current from the first circuit, the current was flowing up. Okay, so 0.5, and in the then we have taken this circuit, and in this circuit also the current is flowing up, or you can say towards the resistance. And in the third circuit, the current was flowing below. So this is this. So that's why we have added 0.5, 0.375 and subtracted 0. Minus, or you can do 0.125 is subtracted to get the effective current as 0.75.